This video will cover notes 3-5 and 3-6. So we've looked at domain and range of relations. So our next question is going to be, is the relation a function? So your answer for these questions will just be yes or no. So to define a function, this is a relation, so that's again where you just have x's and y's, so whether it's a graph or ordered pairs or a table or a mapping. A relation in which each input, which is your x or your domain, has only one output. Which is your y or your range. So the easiest thing to do is think about the function as a machine. If you put in a 5 and it spits out a 7, then later on, if you put in a 5, it has to spit out a 7 again. If it spits out anything other than a 7, then your machine would be broken and it is not a function. So your job is to look for the x's and see if there are any that are repeated. If there are, then you need to look to see what the y values are. If the y values are also the same, then it's still a function because the machine worked properly. If the x's are the same but the y's are different, then your function, it is not a function. Your machine is broken. So an example of a function would be like 5, 2, 3, 7, and 4, 5. So those ordered pairs. An example of not a function would be, let's say we had our 5, 2, and 3, 7, but then I have 5, 6. So first 5 got put into the machine and it spit out a 2, then it got put in again and spit out a 6. That is not a function because 5 goes to 2 different numbers. So when you have a list of ordered pairs, you're looking at the x's. 5, 3, 2, 0, negative 1. Those are all different numbers. Nothing has been repeated. So no matter what the y values are, it honestly doesn't matter. It's just a yes. Some of you are probably thinking, well, here, these two numbers are the same, or these two numbers are the same. Those are y values, so it doesn't matter. The output doesn't matter as long as the inputs are different. So that one is a function because each input, the x values, didn't get repeated. Number 2, when you look through, you should notice that there's 2 negative 4 and 2 positive 4. So we put a 2 in and it spit out negative 4, then we put a 2 in and it spit out positive 4. That means it's broken. So it is not a function. So the answer is just no. Number 3, you have a negative 3, negative 1, and a negative 3, 2. Same x's but different y's, so that is not a function. Number 4, all of your x's are different, 1, 2, 3, 4, and 5. So again, the y values don't matter as long as there are no repeated x values. I'm sorry, I wrote no and it should be yes. Same thing with the table. These should actually be easier because they're already in a row. So if you notice, there's a 3 and a 3. 3, 5, and 3, 3. Those are different, so it is not a function. Number 6, all of the x's are different, so it is a function. Again, these zeros do not matter because they were different x values. So as long as you have different x values, it doesn't matter. Number 7, all the x values are different, so yes, it is a function. Number 8, we have a 4, -3 and a 4, 2. So same x's but different y's means it is not a function. Number 9 usually confuses everybody. This actually still is a function. Again, the y value doesn't matter as long as the x values are all different. So none of these are repeated. It does not matter what the y values are as long as your x's aren't repeated. Now, one thing I want to show you is if they would have put this as a -8 also, we have -8 repeated, but the y value is the same. So it actually is still a function. All right, so even if they repeat the exact same ordered pair, then it doesn't matter. That's still a function. Number 10, all of the x's are different, so yes, it is a function. When you have a mapping, this is actually probably the easiest way to tell. Number 12 is the only one that is not a function. And here's why. This x value, -1, has 2 arrows coming from it, meaning that -1 gets mapped to 2 separate numbers, which breaks the function rule. So this is a no. So with function or with mappings, you're just looking at the arrows. This doesn't matter, all right, because that's a y. You're looking at the x's. Each x only has 1 arrow, so that is a function. Here, this x had 2 arrows, so that's why it's no. 13, they all have 1, so it is a yes. So when you have ordered pairs or tables, you're looking at repeated x's going to different y's. That makes it a no. On the table, you're just looking for x's that have more than 1 arrow coming from them. Then we're going to look at graphs. To check if a relation of a graph is a function, we do something called the vertical line test. If a vertical line, so that's up and down, passes through more than 1 point on a graph, it is not a function. And I'll explain why when we see an actual picture. So if you draw a vertical line up and down and it goes through more than 1 point on your graph, then it is not a function. So if you want a couple examples to be drawn, that's my x and y axes. A regular line, a regular slanted line, will always be a function. If you have a closed shape like a circle, that is definitely not going to be a function. Right here, we already have a vertical line and it goes through once and twice. So it's not a function. So when you have a graph, you're looking at, and maybe you want to actually draw it, is there anywhere where if I draw a line up and down, straight up and down, will it pass through more than 1 point? Well, for 14, these two dots over here, these 2 points are on the same vertical line. So this is a no. It does not pass the vertical line test. For 15, and if you need to think about drawing all of these lines, the nice thing is they're already on lines, but all of these only go through once. Some people say, well, what about this? That's horizontal. So that doesn't matter. It's only vertical that matters. So this one is a function. Each x only has 1 y. If we go back here, this ordered pair would be -3, 1. This ordered pair would be -3, -4. So if you listed them out, -3 would be going to two different numbers. So that's why the vertical line doesn't work. 16 is just a regular line, so that is a function. 17, there's lots of places that you can draw your vertical line, and it passes through more than once, so that is a no. 18 is a circle, so we already drew that one up there, but that's also a no. A lot of people think 19 is a no, but it is a yes because vertically it is fine. Horizontally, yes, it passes through more than one, but vertical is the only thing that matters when we're doing functions. So that is a yes. Number 20 is a vertical line. So this line is going through every single ordered pair. So this is a no. And if you're not sure, just pick 2 points. This would be the ordered pair 5, 2, and this would be the ordered pair 5, 4. Two x's that are the same that have different y's. So that's a no. 21, horizontally no, but vertically is fine. So this is a yes. So again, to be a function, each input, each x value can only have one y value, one output. So if you have repeated x values, if they have different y values, then it is not a function. However, different x values can have the same y value. So 3 could go to 7, 5 could go to 7, 9 could go to 7. That doesn't matter. It's the x values that if they are repeated, they would have to go to the same y value in order to be a function.